that one doesn't work. Sorry. So, what's our topic today? Today we would like to make a critical review of our interest group, and we start with a short introduction on the FAIR Digital Object Fabric, what we are intending to do, and we will look back about what we have reached in our aims. And of course, a critical review is we are happy to get your input. Then we will have a couple of lightning talks, very short talks. We won't have a discussion directly after that of each of the talks, but we will have a big discussion because we are collecting controversial issues, and Maggie will lead the discussion for that. So in this case, I think we could start, or? So also for our virtual guests, welcome. And Bob is looking at the Zoom and looking for chat messages and questions. Okay, what are we doing at the IG FAIR Digital Object? So, a FAIR Digital Object, what is it? So, let's make the simple definition. It is a representation of research data or something else digital, and that contains all the information for fairness. So it has some data content, links or directly data content. It is referenced and identified by a persistent identifier, and it has properties. It has properties which are described by metadata. And one of the important properties of the metadata is the type, because if we know the type of an object or of a data object, we can perform something with it. We can perform actions with it. So, but in principle, we would like to talk about it's a general concept. It's long-lasting, since it is a concept, and sustainable. It took us about, I think, 10 years to accept that PIDs are mandatory for research data management. And also we look at this kind of a concept as a general one. We will see how it evolves. Maybe in 10 years, we won't call it FAIR Digital Object Concept anymore, but something else, but it will have these attributes somehow. In principle, the concept is technology agnostic. It can be implemented in various technologies, whether it's linked data or something else. It is interoperable, and it's for harmonization, and it bridges between research data repositories, disciplines, and many other things. So since it is a top-level kind of representation of research data, so which means that we can seamlessly integrate also legacy data, and most of our data is legacy data nowadays. And okay, since the data has a type, we can perform operations on the data itself. Because of, okay, you know, from your computer, if you click on a file which has a type, a JPEG image, yeah, well, you get the image and it will be displayed. So, and the question is how to implement. Now we have a lot of implementations. I show only one viewpoint of the implementations now, which is based on the recommendations of RDA, of the PID information types group, of the data types registry group, of the PID kernel information group. And here, such a representation can be very, very simple. So we just have a PID, and the PID has an information record, and within this information record, we will find some information. So for example, how the information record is being structured. So this is the profile. Of course, we have information of a type, where the data is, the location role, and so on. And more or less, that sounds simple, that's it. At least here at this point. But it's getting interesting if you could try to implement it and you go down into the specification and you'll find out what are the things which are missing in the specification. Okay, now coming to our group. The FAIR Digital Object Fabric Group. What a name. Has been founded with the beginning of RDA, and it has a former name, Data Fabric, because there were lots of components created in RDA, and the question is, how do they fit together? And now we transformed it into the FAIR Digital Object Fabric. So, since we are an interest group, we are a coordination and communication platform. We founded or wrote a new charter 2 years ago or something like that. And you see the link over there. And we also did a kind of a collection of expectations from our participants and so on. And these are more or less here represented in the Breakout. So developer support, coordination, and these kinds of roles. So we defined internally three different three different objectives. One, our platform is for exchanging experiences about the implementation and application. Then, FAIR.io for pedestrians. Since the FAIR Digital Object concept is a bit hard to describe, especially for beginners. We are collecting information and elevator pitches and introductory materials about the FAIR Digital Object concept. And of course, we are bridging with another organization, which is the FAIR Digital Object Forum, yeah, with the link over here. So let's just shortly review what have we done. And so, first, the aim, exchanging experiences. We have monthly meetings, regular meetings every fourth Thursday of the month. And within these meetings, we have we have working meetings where we sit together and try to solve problems. And we have project chairs. Project chairs in which developers and others show their experiences in the implementation of FAIR Digital Objects. And so far we had 15 project chairs. These are project presentations and lots of discussion, of course. And then we have collected a couple of information and so on. And of course we are organizing these kinds of plenary sessions. To try to summarize, I think we are doing roughly well in here. We will continue the project chairs, and everything what we are doing is open anyways. So, second, aim, bridge with the FAIR Digital Object Forums. This was the last in my former list. But this is something we are doing with persons. So, example, Maggie here, she is in the technical advisory committee of the forum. She is in the working groups, Rob is in the steering committee. And we have lots of people also sitting here who have their feet in both organizations or groups, yeah. And then there's also a further idea. We could go into the direction of creating a joint working group between bridging these both organizations. Okay, let's look at the third aim. This is FAIR.io for pedestrians. Here we want to collect and create elevator pitches and introduction materials. The idea was born by Maggie half a year ago, a bit more than half a year ago, and we started to collect materials, and here we are in the middle of the process. Here you see a Google Drive where we see some of these collection, the FAIR Digital Object elevator pitches, tutorials, presentation, and pictures. And this is also something. Here you see a lot of pictures, I don't explain them. But you see here different kind of presentations, how a FAIR Digital Object could look like, or it could be depicted somehow. And you see all of them are different. And currently we don't have a real unique and nice view. This one is nice, but wrong. This one is one of the older ones, corresponds over to here, but it gives you the impression that it's an egg, a container, this contains everything. Maybe it's not. Here we see more processes, and here a depiction of how the PID information record is organized. Well, more or less, that's it. Do you have some questions directly to FAIR Digital Objects or to the group? If not, we can continue with the elevator pitches. We are changing chairs.
It's the lightning talk.
Yes.
Yeah, we are exchanging chairs,
Yeah.
and Lori is now chairing the lightning talks.
Oh, hello everyone. It's time for the lightning talk. It's my honor to have three excellent speakers here to give us some lightning talk. Maybe I think they will give us some insights about the FDO. And first, we will have Professor Zhihong Shen. He's also from Computer Network Information Center, Academy of Sciences. He will show us his new progress about the collaborative data flow system. So, please. And I think I have to remind you have only 10 minutes.
Okay.
So actually, he's my boss, but I also count the time.
He needs a microphone.
Hello everyone, I'm Zhihong Shen, and I work for the CNIC, Chinese Academy of Sciences. Today I will share with you some work about data flow. It's an end-to-end collaborative data flow system. Background. In the past 4 years, the Chinese Academy of Sciences had created a system of scientific data centers. And this system consists of more than 30 centers in 3 levels, including a general center, several discipline centers, and some institute centers. Actually, the general center is operated by CNIC, by our group. So as a general center, our task is to verify the research data distributed in different centers. And we define the integration standards, develop a set of tools, including the management tool, publishing tool, etc. And we deploy tools in centers. Then we build a set of data services, including a web portal, a search engine, and so on. This is our task. And then we realized to build an end-to-end data supply network for research. Finally, we decided to develop a system named BigFlow. And BigFlow is designed to be used different datasets across distributed centers and to employ different computation services and models and to resolve their final problem. This is the BigFlow. This slide shows the software architecture of the BigFlow. We designed 4 layers in the BigFlow: a data access layer, a digital object pool layer, a schedule layer, and a data flow engine layer. We also provide web UIs for data flow design and monitoring. And the BigFlow is designed to support popular big data systems like HDFS, Hadoop, Spark, and so on. In the BigFlow, we defined 4 kinds of digital objects: datasets, processes, flows, and sites. A dataset means that data source, like a SQL table, a file in the HDFS. And the processor means a program for dataset analysis. The flow means a chain of a series of datasets and processes. And a site means a machine where datasets and service host in. And each site manages local computation and storage resources. The right part shows a simple flow. First, we load data from a file A. Then we sum total scores for students. And finally, we store some into a file. And in this example flow, It consists of 3 processes, and the file A as the input data is a data set. And the concept of a data frame is a very important concept in the design of the big flow. We defined the data frame as an in-memory data table with schema, where schema means the properties definition, including the property names, property types, and so on. So a data set actually is a container of a data frame, and the schema of the data frame should be provided to describe how to create a data frame from a data set. And also each process takes data frames as input and output. We define the data frame interface. This interface is ready to process in popular big data engines. This is how we define the concept of a data frame. And the right part shows the schema of the file, input file and output file. Process means a program for dataset analysis. So it contains metadata information. It includes the name, description, and other settings. Also, it describes the program language, in which language the process was written, like C language, Java language, and Python language. And a flow means a chain of a series of datasets and processes. We note that each process takes data frames as input and output. So the schema of the data frame.
No, the microphone's not a problem. The back of the room is having a little trouble hearing. So if you could speak up louder.
Okay. So the schema of the data frame for input and output are required to be specified. And if a flow gets a wrong input data frame, the flow will fail. This slide shows the main ideas in the system implementation. First, digital objects are auto-discovered on sites startup, and a digital objects core is built on the leader node, not in a centric registry. Also will follow the principle, move processes. Do not move datasets across different centers. Until now, the big flow software is written in Scala and provides Java and Scala APIs. More than 100 common purpose processors are provided in big flow. The user's processors written in different language are supported in big flow. We have applied the big flow in some research programs. This slide shows one case in a vegetation protection use case around the Yellow River area. In this case, we have constructed an ecological value assessment network including 4 data centers and nearly 20 analysis processes and terabytes level datasets. Another case is about ecological monitoring use case, and in this case, the big flow connects 3 data centers, sub-centers, and stations. And we developed 100 analysis processes and built 4 data flows to help the data collection, quality control, product release, and sharing. Okay, summary. The Chinese academic sciences has created a system of scientific data centers. And as a general center, we verify research data and aim to build an end-to-end data supply network for research. We built an collaborative data flow system called Big Flow, and Big Flow manages digital objects in a dynamic form located at the leader site. Finally, we applied big flow in some research programs. That's all. Thank you.
Thank you very much. It's just 9 minutes. And as we know, how to use FDO is very important. And in the next talk, we will have, in the next talk, we will have Nicholas Blumenrock, sorry for the pronunciation. He's from KIT, and he will show us some, give us a talk about FDO applications.
Nicholas, may I just interrupt you? I'm sorry, in the introduction, I forgot something very, very important. I'm just jumping back to all the slides and just to the beginning in here. Please sign into our collaborative notes. This is something because we would like to know who was here, but of course it's voluntary. But I see here lots of people, full room. I'm really astonished, and we have 20 other people online. So this is here, if you would like to, this is the link. So I give you a couple of seconds. 1, 2, 3, done. And now, Nicholas, I'm forwarding to your slides. Okay, here we are.
So, hello everyone. I hope you can hear me in. Okay, great. Yeah, so my name is Nicholas Blume. I'm from the Karlsruhe Institute of Technology, and today I would like to talk about some fair digital object application cases that we have been working on during the last year. And of course, in this frame of this talk, also the achievements which we were able to accomplish, and even more important, the challenges that we faced during the implementation, and the possible conclusions and possible perspectives for future applications that we draw from that. So, the implementation of the fair digital object concept, how we implemented it, took place in the frame of 2 application cases, which were related to machine learning, to the field of machine learning. The first one was actually addressing the task of composing a training data set for machine learning, where we used the fair digital objects to at least semi-automatically put this task onto machine actionable decisions, and this was mainly concerning the task of relabeling, which is in this case simply the assignment of label terms from different data sources, which need to be assigned to the same category. For example, in order to train a supervised classification model. And here on the right-hand side, you can see how we designed, in this case, the fair digital objects and how are they related with each other. So here we simply have 2 FADOs that represent the data and the corresponding metadata, including the labels. And this is visualized with a software called Fairoscope, which can be used to visualize but also explore the fair digital objects that are provided via the PID. And this shows us how these objects are related, which attributes have been used, and also what are the types, and of course the data sources that are represented by these FADOs. Another application case in these regards also concerned machine learning data, which was used to train a model. And here we tried to represent multiple data assets of different kinds and link them together. And this included images, but also annotation files, and also experimental metadata documents. And as you can see here on the right-hand side, this is a much more complex network that comes out of it, which is part of this of this architecture. And this is even just a fraction. But here we already see very nicely that using the fair digital objects provides us the possibility to connect these data assets irrespective of where they are stored. And if you want to know more about these application cases in detail, you can follow the links below or just get back to me. But I want to take the chance to also talk about another aspect which was relevant, especially for the first application case in the former slide. And this concerned the implementation of a client system that can actually use the information of the fair digital objects. And this is, I think, a very relevant point, because we always talk about the fair digital objects and say they need to be, and they're supposed to be machine actionable. But they seldomly, this machine actionability is seldomly going beyond the very basic CRUD operations. And what we did therefore was to define functionalities a client should be able to carry out. And this also worked by using already existing services like a type PID maker instance, which connects the handle registry, the PID service, at the data tab registry. Our client was therefore capable of resolving PIDs, getting the information record, validating the profile, and then carrying out the operations that are necessary to carry out the relabeling task. And in this case, it was simply a set of class methods that worked with the information in the attributes values in the information records. So now I think we can somehow summarize that based on the concept that we already have, and that is, I think, also applied, of course, in other domains, already provides us with some important possibilities, including to find the data via the location path, evaluating if the license is reusable, and all of these things. But I guess I would say now we should look what else is coming next and what we should concentrate on. And I formulated 3 main points that I thought or I consider to be important here. First, regarding the granularity of data representation by the fair digital objects. So currently, in principle, you can represent any kind of data asset as a fair DO, but the question is what is most feasible, also in terms of different applications. So, for example, we dealt with data that was existing as a data set of multiple images, and this was already stored as a data set in the respective repository. And now you could argue that it is probably even better and more appropriate to represent each of these images within the data set as a fair digital object and connect them via a collection. Or we stick with the other approach and just represent the entire data set as a fair DO. And the question is where to draw the line here. What are probably the best practices and guidelines we should follow? And also with respect to the restrictions that are made by the storage system. So what does the repository actually enable to store? And this is also relevant for defining the fair digital object. Then another point regarding granularity is the information record granularity. So up to now, we mainly have, of course, the kernel information, which is a set of general information, like location, license, etc. And this works fine for certain machine actionable decisions. But once it comes to more complex use cases and more complex operations, of course, the information that is required will also extend. And the question is, how will that be facilitated and implemented? So will we go with a linked data approach here? Or do we want to extend the information record content? For example, I can think of that the type which defines the fair digital object operations, which can also be a fair digital object itself, might contain more specific information about the data. But this is really, for me, also an open question. What are the best practices here? Yeah, and last but not least, again, regarding the operations, I think it's now time to go a bit more in the direction of specifying the particular operations that we want to use, and we want to, let's say, implement for our machine actionable decisions on the data. And the two most important aspects here are, of course, how and where to define these operations. This is something that has also been addressed in other communities like the FDO forum, and there was a lot going on in the discussion regarding registries for operation, for example. And then, of course, the question, how is that then brought into production? So how do we implement these operations in the end? Is it a server? Is it a service that runs somewhere? Or do they need to be brought into local systems? This is also not yet fully clarified. So with these questions and possible future challenges, I thank you for your attention and give back.
And next, we really talk about data objects, and in the next, we will have Daniel Katz. He will give a talk about their non-data objects.
Thank you. Okay, thank you. Yeah, thanks to the organizers for the opportunity. I'm actually a little bit surprised because I gave a similar talk to this in one of the meetings, and I thought it was a little controversial and negative, so I didn't expect to be asked to talk again.
That's a reason.
But indeed, I was asked to talk again. I'm giving the same talk, so I apologize if you've heard this before. And some of this is actually from the Fair for Machine Learning discussion this morning as well. But basically, I want to talk about fair non-data objects. In particular, I think everything that has been said before has talked about fair digital objects, but everything has been data. So I'm not quite sure why digital is D, and it seems like it's actually data in this context. So if we're thinking about fair for non-data objects, the FAIR principles came from the idea of doing things for all research objects, but the people that actually wrote them were really thinking about data primarily. And so there's a lot of data inherent in the ideas, even though the claim is that this is more general. The text in the principles often includes metadata, which stands for metadata and data. The principles are applied by dataset creators and repositories, and collectively these two organizations create, annotate, index, preserve, share the data sets and their metadata. And this assumes that there are separate and sequential roles. Somebody creates the data set and then it's published, and then the repository takes over and it does its part. But if we think about non-data objects, they can be stored as data, but they're not data. And so the pictures at the beginning that René was showing, where they talked about a series of bits, the software is a series of bits, but it's not just a series of bits. That's probably not a very useful way of thinking about it. And so that's kind of the aspect that I want to talk about here. The high-level goals of findable, accessible, interoperable, reusable are the same for non-data objects as they are for data. But the details of how they're implemented really depend on the characteristics of those objects themselves. How they're created and used, where they're stored and shared, and where metadata is stored and indexed. And these are not the same for non-data objects as they are for data. So there's work that's needed to define and implement and adopt these principles for other things that aren't data. In particular then, okay, right, so the FAIR principles are intended to apply to all digital objects. So I'm just going to try this. No? Okay.
I'm sorry if I messed up in copying the slides.
No, I don't know. I'm not sure what's going on, but so there are recommendations from the FAIR Practice Task Force in EASC that said that FAIR guidelines require translation for other kinds of digital objects, and that needs to be supported. There's one from the French National Committee for Open Source Science Free Software Group that said, make sure the specific nature of software is recognized and not considered as just data. And so what we were doing in one of these working groups was focusing on the adaptation and adoption of the FAIR principles to research software. And so this isn't the only thing that's happened. This has been, work has happened in terms of research software, in terms of training materials, in terms of computational workflows, in terms of machine learning, and in terms of VREs. In all of these cases, there's been a recognition that these things are not data and that we need to do different work to figure out how to apply FAIR principles for them. So the reason in terms of software why we do this is that software is data, but it's not just data, as I mentioned. Software is executable while data is not. Data provides evidence while software provides a tool. Software is a creative work. Data are generally facts and observations, although some people will probably want to debate that, but I'll say it for the minute. They have different licensing and copyright practices legally. Software suffers from a different type of bit rot called collapse than data does. Right? Software stops working if its dependencies change, and that's completely different than how data stops if it gets stored in a format that's changing. The lifetime of software is generally not as long as that of data. Again, we can debate this one. And the big issue really is that for open source software, there's no natural process that's like there is for data. Right? You don't write open source software and then put it in a repository. It's in GitHub the whole time you're writing it. Right? People use it before you put it in the repository. Right? There's no identifier that goes with it. So there's a lot of differences here. There's no metadata that gets stored anywhere. So differences. So in this group, we had a working group that then was defining FAIR principles for research software with a bunch of us involved, 9 of us. And then 5 more people that came in as subgroup leaders. This was a great community effort. This is, I think, really a model of how a working group should work, I think. And we did this as a joint working group between Force 11, RDA, and RISA, the Research Software Alliance, to try to get really all the people in the community involved as much as we could. So we came up with a set of principles for refinable. Sorry, this is. I don't think I had this animation. So I think that's the end. Okay, sorry, this one got messed up a little bit. That's okay. But anyhow, the main point is that the high-level principles change a little bit. Findable, accessible don't change very much. Interoperable and reusable change a lot because interoperable and reusable mean very different things and even uncertain things for software. We made a particular set of choices. You could have made other choices. And so the things that are in italics are different. The things that are not in italics are basically the same as for data. And I don't know what else is going to happen underneath. Maybe some more stuff is showing up. Okay. All right. So what happens actually after these principles is that the FAIR principles need to be applied by the creators of software. The principles have to be enabled and supported by a bunch of different stakeholders. And this includes repositories and registries, but it's not just repositories and registries. These principles expose ecosystem gaps, particularly related to metadata archiving and versions, which are different than the gaps that exist for data. Again, the main thing is that this creator and publisher series sequence that happens in papers and happens in data doesn't happen in software. And that leads to these interesting questions. There's questions about where metadata is stored. It can be stored in a code repository if it's open source. If you have closed source, there's no clear answer as to where metadata gets stored. It can be in an archival repository. It can be in a registry. It can be in a package management system. So there's no standardization here. Where the code is archived is quite different as well because GitHub and GitLab are not archival and they use the word repository in a different sense than an archival repository does. Software heritage has an interesting model that maybe helps answer some of these questions, but it's not very widely used yet. There are different use cases for software where you want a specific version or you want the latest version or you want all versions. And some of this carries over to data, but it hasn't been, I think, the focus of a lot of data work. And then there's just a lot of work beyond FAIR. So if you're talking about making software fair, that's great, but you also might want to talk about the quality of the software or the correctness of the software or the reproducibility or the openness. And these are not necessarily things that all apply to data. And so they're, again, just different things to think about. In terms of the FAIR for machine learning work, where we had a meeting this morning, the original FAIR principles, again, work on scholarly digital objects, really focusing on metadata and data. FAIR for research software focused on research software, but what about machine learning models? Are they data? Are they a set of parameters and options for a particular framework, which you can kind of think of machine learning models as? Are they software? They're an executable object that takes input and provides output, so maybe that's where they fit. Or maybe they're a combination of data and software and workflows, and we don't actually know what the right FAIR principles are for models yet, and we need to work on it. And maybe there's something else. So if we want to apply FAIR, again, we have this issue that FAIR for data is dependent on archival repositories. Those hold the data and metadata. Software is different. It's shared via coding platforms, package management systems. ML models are searched and shared via repositories, maybe, but maybe they're searched and shared via executable platforms. Maybe they're searched and shared through something else like DL Hub or OpenML or Hugging Face or something else. So we also have the fact that models and training data are linked, and should they be shared together even though they may have different principles? And the answer is probably yes, but we don't know exactly how. Okay, so having said that, we had this meeting this morning, which again I mentioned, if you're interested, there's lots of stuff, collaborative notes are available. But let me just wrap up by saying that I have some concerns about this group, and again, we may disagree, but I'll just express my concerns. One of them is that I believe a failing of the original FAIR principles where it's biased towards data and just data at a detailed level. And now we have lots of different groups that are creating new FAIR principles for different types of objects. And I think eventually we're gonna have to try to unify these into some actual high-level FAIR principles that don't just apply to data, but apply to everything. I think FAIR DO seems to be repeating this. And so we're gonna do this, and then we're gonna have to do FAIR DO for software and FAIR DO for models. And I don't think that's necessarily a good thing to go through. There's this quote, the International FDO Forum will bring together infrastructure researchers, all this other stuff. And I don't actually see software or software developers in that list, and I don't see anything about machine learning model in that list. So I feel like there's big sets of the community that are actually completely absent from this discussion, and that's potentially a problem. FAIR DO seems to be a misleading name, as I said. We aim towards a new infrastructure and architectural extension of the internet of FAIR data and services. Okay, that's interesting. I don't actually see digital objects in there. I don't see software in there. I don't see machine learning models in there. I see a new internet in there, which seems confusing. So what are these digital objects except for data? What are the services that are here? I don't know that yet. How does an architectural extension of the internet actually fit into FAIR? So I'm a little confused as to some of these things. But maybe I'm wrong. Maybe this has all been thought of, and I'm just coming out of it and looking at papers without actually talking to enough people. So the thing that I want to just leave you with is that we do have members of the FAIR RS community and the FAIR ML community, and we'd like to help, we'd like to be involved. We haven't been approached too much other than me. I hope we can, and I hope we can actually work on this collectively and do something that's not just another FAIR for data. Okay, that's enough. Lots of people helped. Some of them are in the room. Thank you to them, and thanks for listening.
Now, thanks again to the three speakers. And the next we will have some discussion. He mentioned many of problems, so maybe we can have a discussion in the next. So I think Maggie will take over the session. Is another thing.
Yeah, thank you very much. No, I don't need that.
So actually here.
Yeah. Thank you very much, Dan, for being very straight and very honest with your views. I think it's extremely important to voice concerns and do them also. I mean, really work at it in detail. I have a problem with this. This doesn't sync with what you said over there, etc. Before we kick off the actual Q&A, so to speak, because I'm really hoping for a very, very active discussion here now involving both people in the room and online. So everyone just who is online especially, add your questions and comments to the chat, and Rob will help me to facilitate the connection with you. And everyone in the room, just wave your hands or whatever. Yes. So we have one person who wants to say something. One second. I just wanted to say that the landscape, so to speak, of the fair digital object discussion and development is a little bit complicated because, as Rainer started to explain in his presentation, there is the Fair Digital Object Forum, which is not a part of the RDA. And then we have this group here within the, or under the roof of the RDA, which then started with this data fabric, but then thought that it would be more opportune and more inclusive, maybe to a more actual and modern, to talk about this digital object instead of the fair ones. So just wanted to make that clear so that we all know where we're coming from. And of course, many of Dan's points on the last slide were really addressing statements that have been made in this external group, which is operated under the Go Fair Foundation. But nevertheless, I mean, we need, if we don't agree with those kinds of things here from the RDA point of view, we also need to be very clear and very honest, and also point out any distinctions in views and whatever. So let me see if I can go back to yes, the last slide of
The last slide.
no, the last slide from Dan.
Here we are.
No, from Dan.
Ah.
Yeah, because I think we should.
I destroyed it.
It's not fair, Rainer. Yeah, now it's disappeared. The whole screen sharing is gone.
I will try. You continue and I will
Yes,
try.
thank you. Yeah, so the first thing about your criticism is that you were wondering where the other non-data items were, and I think that's a very fair question. I think, however, that the discussion up to now has been very focused on sort of understanding the metadata structure that is required to define a fair digital object, and we're not here to talk about the details of that today, so we don't have the appropriate slides to illustrate that. But so I'm not that scared that we will not be able to map out and include also non-data objects into the general digital object framework. But we need to start looking into what the specifics are of these non-data objects that doesn't match in now into the data picture. You're getting there, Rainer. So, are there any views in the room of how difficult that would be? Yes, loads of people. So I will go to Herman in the back. Can you try to speak and see if when you're in the room will understand?
Online here is when
Have it.
Yes, thank you.
In the room, you don't need a mic. You can
No,
just speak up.
it's for the online people, right?
You can start to speak up over there.
Yeah, but the people online.
There is some mics scattered on the ceiling.
Yeah,
Oh,
there are
they are
mics.
connected.
Yep.
Oh yeah, then I don't need this. I have a loud voice.
Go to the back.
That's your place. Anyway, before I get to that, I had two things I wanted to remark about the machine learning thing. First of all, I think that with Git-based repositories, which I agree are not archives, that you can link to very specific things there, because to any specific version based on the hash of the commit or the place of the tree. So to say, oh, we don't know what version it is, that's not fair. You just need to create a better link. Yeah,
Right, but that's not a PID.
no, that's not a PID. You can have a PID that links to that,
And what do we do when GitHub goes away in 5 years?
but it's not an archive. But GitHub is just a host for Git database, so you can put a Git database of the specific project somewhere else and the hash would still work. Anyway, it was a very small thing, not important. And what you said about the machine learning models, in industry, right, so where I work, the current practice seems to be that if we're looking at operating models of machine learning, we we have 3 cycles of things that we version, and there's the data, there's the model itself, that is how it's created, and the artifacts that starts off the trained models, and there's the software that actually uses the model. So that's 3 things that are considered to be separate things. You don't have to do anything with that. As to the fair digital object things, to me, it seems what we need is just some, okay, just is maybe not the right word here, but some practical implementations that some people just try it for something, see how far they get, then crash and burn, and then we do it better next time. To me, it feels that we're at the point of the discussion where we should stop discussing and just do 1 or 2 or 3 different things, and then mash them together.
Just, so I think that seems like a very good idea. I guess my suggestion would be that at least one of the use cases that you do this for is not just data.
Yes.
But
No, I agree.
Do I need a mic?
Well, just speak up.
Oh, okay. So maybe this group here can help me out. So I've been thinking about this fair digital object, not so much as a fair digital object, but more like a fair digital token. And that when I think about my work, I think about like, well, there's the people who participate in the work, and so they have ORCIDs, right? And then I think about the institution that participated in the work, and they have their own IDs, and then we have like instrument PIDs, and then you have like your data, and then you have your code. And so, I mean, for me, it's more like it's more important how those tokens are all co-represented. But maybe I'm thinking about this wrong, and if so, like, let me know. Maybe I'm in the wrong room.
I can try to give an answer on that. So for me, a fair digital object is an overall representation of a data object, not just research data. Since we are in RDA, research data, of course, is somehow in the center. But it's a general representation, and the general representation makes it machine actionable, I would like to, but at least machine interpretable. In most of these other systems, I result in a landing page, which are for humans. And then normally, if I come with a machine to a landing page, here everything stops.
Yes, I think just that we have a standardized method, which does not mean that you have a standardized, except for a minimum standard, terms of attributes that you need to associate at basically the registry level of your digital representation of any kind of object. So that really helps the people writing the code that is going to be doing this machine actionability. I don't know, I just wanted to say that in another context where this thing about machine actionability came up, a lot of people protested and said you shouldn't call it machine actionable, it's software actionable, because it's not the machine itself that was doing the intelligence, but now with the chat robots and stuff going on. Yeah.
Okay. I would Judge Chokin? Okay, I would point out that machine learning is called machine learning and not software learning, but anyway, that's not my point. So my sense with FDO, and I'd like you to clarify it, is that the key was each data object was individually addressable, so each one had a persistent ID and a common protocol, so you could pull this thing out wherever it was residing. And that's where the internet thing comes from, because you can individually access the machine. So that's where that came from. And then the other piece of it was that once you pulled it out of wherever it was, the type to that object was something you could act on that could act on that. In the case of software, it might be a makefile or something, but there's some action. And that's the core. So I would ask people like Nicholas, because I know I can pick on him, what are the key types? is the protocol critical here, the computer protocol, and what are the types that are being defined? I'm sorry, I'm putting you on the spot, Nicholas. What are the types that are being that are being defined here that are unique? And I would say that for our gentleman here from China too, who had defined types, a process and a data object, and what are those types? How are those types being used? So I guess that's a big question, I guess, to ask a question to a number of people. Nicholas, go ahead.
Yeah, maybe I can start. And yeah, the type question is still something which is highly discussed. And what we did in our application cases was mainly concentrating still on the MIME types. But I think one essential part was that we also represented the type itself as a fetched object. So you had, when you had your data, let's say an image or whatsoever, you had in the information record pointing in the type attribute to another PID, which has all this information gathered. And this included the MIME type, but also other additional information, like, for example, versioning, the schema a document is based on. These kind of things, which are very specific for this particular data asset, and now is the question how to relate this to a particular operation. With MIME types being a good basis, but I think we could probably go even further, specifying more. But yeah, this is also a big task yet.
Yeah, so underexplored.
Yeah.
Maybe I will ask you some question because you asked the Chinese. Oh, sorry. Just now, Mr. Shen gave a talk about the big flow and mentioned the different types of data objects. And in our use case, we have two solutions. One of the solution is use the PID system because. Oh, sorry, maybe I should be louder. And in China, we have a a PID system called STR, and the type will be registered in the PID system, and it will be showed in the PID, in the ID number. So both data, non-data, such as even researchers could be a type in the ID, and to be interoperable, we also do some work about the metadata. We designed a vocabulary to register different kind of resources. So here is the solution now for us.
And can you act on those when you register different kinds of resources? Is there some actionable action that can be taken on an individual resource based on the type?
To be honest, we try to do that, but only some of them can be actionable. But it's working on.
Thank you for that.
Yeah. So the thing with GitHub is that when we build software, we don't actually use GitHub as the ultimate designator of what's used in production. You would use typically things like Artifactory and other things that archive a specific version of the build that was made at a certain point in time, certain configurations and all that. Going back, my question to perhaps suggestion to the group is that software can help actually in the adoption of these digital objects, because if the community was creating a single repository from where you can extend and implement interfaces of the known data types that each one defines, it can avoid the proliferation of different models, because if everybody creates their own data type and their own data sort and their own workflow and so on, and possibly if all goes in one place, there can be reuse of certain things that are already in place.
Just directly answer, or?
It's a comment.
Okay.
Let me bring in just a few of the online questions, so we're including that group. There was a question, and Hugh, that Hugh asked me, but wasn't asked in general about, from a machine learning perspective, do transformations of the data set get inherited by the fair DO, or do they get copied into a new fair DO, which I think is goes back to a granularity question. And I would, my own opinion there is that they would become a new fair DO, but I don't know if anyone else in the audience may have a different perspective on that. And I know this is more of a question for the fair ML group, but oh, you don't need this mic, that's right.
So I was just gonna ask, is the transformation a fair digital object, or are we just talking about the data sets again?
So I think the transformed model.
Well, what about the transformation itself?
Yeah. So I would say that yes, so even that should be recorded and is part of but it's more of a software component that makes the model. So yes, I think that the fair digital object architecture itself says everything is an object, which I think meets more of what you were saying. And there was a question in the back there, if someone wants to ask, and then I'll go back to online. Go ahead.
So basically, I have a comment on the question. I was attending the forum, the forum in Leiden, and I think the big confusion in this discussion is that when you look at the original formulation of what Bob Kahn and Donald Foundation did, they talk about the protocols, and they don't not about building something on top of HTTP,
Yes.
which we discuss here nowadays, and by building something parallel, yeah?
Yeah.
And that's why now we have the problem in terminology. What is data, what is not data, and so on. And I think we should clarify first here in this room, what are we discussing? Are we discussing this Donor Foundation architecture or not? And if not, if we assume that we are staying with HTTP, then my question would be, why don't we just state the definition of APIs? Because API basically defines a set of actions around data, basically it's defined with a service. So I think we need to kind of identify which direction we want to go with the discussion.
Yeah, that's a very valid point, and also a question that loads of, say, data producing organizations that are already working with well, I guess when you say API, you mean a RESTful API and that kind of model rather, because you can also see the digital object interface protocol of the DOIC from the Donor Foundation as a kind of API-based thing, but it's not the same. They are not fully compatible and they do not express exactly the same types of observations for the details of it. But you still do have the CRUD capability and everything. It's just it's not expressed with the get and post and update that we are used to. And I think that's one of the hindrances or stumbling blocks at the moment is people would need to, if they're going to adopt this DOIP way of working, then they need to rewrite their code or at least provide a layer, an interface layer between the DOIP and what they have today, which I think can be a bit of a problem. Do you have any comments on that?
Not directly on that, but general agreement.
If I may,
Yeah,
because I think this leads to the second question. What is the relation of RDA and what is the relation to the Digital Object Forum? Because they also have some working groups. So why do we have two places to discuss the same thing, or are we discussing a different thing?
Well, that's what I tried to explain earlier. I don't know if you were in the room.
I was in the room, I didn't get it.
No. These things are simply founded in different groups of people with different interests and moving forward. I mean, the RDA existed beforehand, but then this forum group was really more on, with a very strong focus on the building up the architecture, which was not really one of the things that we had originally. I see lots of people with their hands up.
Yeah.
But
May I just give a short example? RDA is not doing implementations. It does create recommendations and maybe also specifications, but doesn't go deep into the technology. And the FAIR-DO forum is able to do that. So there is a certain kind of difference between both. Sorry.
There's microphones.
yeah.
Carol, you get the word.
Okay, I get it.
Just speak up.
Okay, so having been to the Digital Object Forum, so I got into that and here as well, I must admit I'm getting a bit FDO weary.
And there were a few people who were going to come to this meeting but said, we're FDO weary because we don't see any progress. So you're in principle, you're right, this is where you implement, but I don't see really implementations other than small exercises which are independent. It's also very difficult to do things like boring stuff, which I put in the notes, like where is the fair digital object architectural spec, right? It's really hard to find, actually, still, to get those comments out. So I think FDO needs to become more open. FDO needs to become more like RDA in that sense, in order to be able to build up trust, okay? And we also need more concrete use cases of people actually trying to do it, rather than going over and over, more and more elaborate, wouldn't it be good if we had this, this, and this type of models? Because then we're kind of moving towards a really complicated model. And then the last piece, I completely support your point, that the FDO should be a pattern. This is how you should be, organizing the objects, and then the implementations. You could have a perfectly adequate implementation using HTTP, which is, I represent Elixir, and there we will be keen on that, because I'm not going to ask the hundreds of data sets and the hundreds of platforms to re-implement to DOI, because I know what the answer will be, and the second word is off, and the first word has an F and a K in it. So I'm not even going to try, right? So these are the things I think we need to do. FDO needs to become more open, more like RDA. We need actual concrete demonstrations of the patterns, the actual patterns, and it should be pattern orientated. And then we need alternative implementations in different mechanisms that we can show how that would interoperate with the model.
So let me say something here, because I did one of those small implementations actually Beth started one of those small implementations, and I finished that small implementation, and Nicholas is doing this now. What we need to do a large implementation is a large paycheck, right? So to pay the people to do these large implementations, and that hasn't as of yet appeared, though I think there is some funding, some national funding coming out of Germany. So it's hard to do more than a small pocket implementation without some sort of backing behind that. And really to do a large cross organization DOE implementation is going to take more money that has been put into doing that at this point. So
well, I agree with that, but I'm going to push it back a bit, because I'm going to say, yeah, okay, I actually have organizations that I represent who have got money to do this, but they don't feel as if they're engaged in the specification process. Okay. And the specification process is not open enough, and doesn't follow practices like proper issue tracking, proper open review, a cadence of a series of different meetings that you normally see in a kind of standards specification kind of activity. I know Bob will probably back me up on this, Bob. So it's a chicken and egg. It's very hard to get a big organisation to back that, and there are people who are ready to back that.
Carol,
they need to see that, right?
Let's cut you short there, because this is now turning into a sort of bashing of another group.
It's being positive. I'm trying to be positive because I want to do it.
Yes, I know that. I also want to do it. I fully agree with most of what you've said and what other people are expressing, and as also part of this other group, I'm also very frustrated at the lack of progress and pace. But so we have only about 20 minutes now to go, so I would like to turn over to these other maybe more general questions. And I don't think that we...
Let me do some of the online systems at the start of this online questions.
Okay.
So I definitely don't want to leave the people online out. So there are a few things that comments that I think are important. And this is almost another layer of complexity on Dan's talk. Zach asked about FAIR principles for non-data objects versus creating digital twins of non-digital objects while ensuring that those digital twins were still fair. So if you want another layer of complexity in the software modeling, you create a digital twin of a software. How does that continue along the line of fairness? So I don't know if anyone has any comments for that, but I thought it was a very interesting point.
I don't see
pertinence to
Speak up, please.
I don't see the pertinence. How a digital twin, I think it's a term that comes up from presenting digitally yourself. So it's a twin of the physical presence. Software is digital natively. So when we're saying create a digital twin of software, what are we talking about? Cloning the software or?
So
It doesn't make sense to me,
non-digital
I'm sorry.
or non-data objects is the question, not necessarily software. So models, so a digital twin is a continually evolving model, right?
Yeah, I don't
It falls
know
into
if
the
it was
model.
you or the other gentleman who said that I don't subscribe to that non-data because it's all data. Software is data, machine learning is special software. So all these things are data. Now, whether all various communities and the working groups should work together, that's a separate matter. I think the answer is yes. But it's all data. If the gentleman can clarify what digital twins means in that sense.
So I don't know if, one, if we have time, and two, if the microphone actually works, if he were to speak and turn his volume off, and I don't think there's a technical person in the room to help us with that. So, and just a last few thoughts, and these tend to go back to, I think, Dan, you brought up some really good questions and people keyed on them. Larry mentions that not all digital objects are the same, so software is different than continually changing sensor data, which itself is different from digital twins representing a scientific instrument. So I think there are many variations on this thing, but in the end, again, I think they all should be able to be represented as digital objects, and we should find a way to make them fair, though that method is different depending on the object type. So, Larry also brings up the point that software does not execute itself, just like data sets do not perform operations on themselves. So,
I guess I would say operating systems.
At some level.
Software does execute itself. I don't know what else does.
Okay. So I will stop there and we can get back to the room and hand back over. Thank you.
Yeah, thank you, Rob, for making sure that also the people online are being heard. I apologize for forgetting that. Yeah, so I just put together these slightly controversial questions in case there were no other questions. But I think one of the first things that I'm still also struggling with is who actually really needs this fair digital object specification as we are trying to describe it or specify it technically, and who really needs this whole complexity and this way of working with data. And I think we've seen some good examples where we're trying to streamline the flow of things, the workflows, making sure that you can very quickly find out from following a PID whether this is an object of the type that I'm actually looking for to be able to process in my workflow. I mean, you don't want to end up with, for instance, you're looking for JPEGs, but you're actually fed, I don't know, CSV files or something that doesn't want. You can skip on to the next one on the list very quickly. But I'm thinking that it's probably, to the first degree, very dependent on the research discipline that you're talking about, because it's about volume, but also really the complexity of the things that you want to be looking at. And probably also depending on the research question or the type of research question that you're asking. Are there any views on that? Just stand up and speak loudly.
I'll just speak loudly. So I have a question about type particularly, right? Because if I were to think about that, I think that means that's another whole like ontology behind what a type is, right? If I think naively, let's just take an example. I open the refrigerator and I'm looking for dairy. Well, then there's like butter, and then there's milk, or do I mean kefir, right? And so like, is there some guidance on that?
If I may just answer, we have here an RDA recommendation of the data type registry, which is a registry where the types are described. The question, yeah, this is the DTR.
Okay.
And Larry is one of the founders of the recommendation.
I should refer to that for the type.
Yep.
Perfect, thank you.
But, so I'm looking for people both online and in the room, if you have suggestions for these disciplines or how to answer this first question, especially, or you can type it in afterwards in the notes document if you want a few more minutes to think about it, or etc. But do you think there are any, we heard about machine learning, that is of course one aspect here, but there are also, I mean, non-machine learning ways of processing large data sets and complex data sets, where I think originally when we talked also in some of these other working groups that have been mentioned, one of the aspects there has really been be able to find out very quickly if an object that you have found through a search, for instance, at the catalog or something, if that is really something that you want to or should be processing. It can be about the type of the object itself, as we mentioned, the MIME type or whatever, but it can also be about very quickly trying to figure out, does this data set contain the variable that I'm looking for? So it's not enough just to go out and search for things that have, I don't know, temperature in them, because also the unit and the measurement method used to get the temperature might be very, very important for your decision, should I be processing this data or not, so that you're not mixing the apples and oranges.
So can I ask a question? Shouldn't because maybe I misunderstood the description of the group here, but if these digital objects thing, shouldn't it be more of an umbrella? That would address a little bit the controversy or discussion that we had earlier about software and workflows and whatnot. Because I was also in a discussion about identifiers for instruments, so that instruments can be specified, and we talked about the fact that an instrument, provides values, but it's not a static thing because it may undergo maintenance. Components may have changed. The environmental conditions can have an effect on how the instrument works, and so on and so forth. And shouldn't all these be under the same umbrella, so to speak, going back to the ontology matter, so that we can speak the same language of how the data is accumulated, processed, and in the end, what it means in the analysis? I don't know if it's a rhetorical question, but it's.
I agree.
I also agree.
Yes. I think you need to couple the instruments with the data, with the software, with the hardware that is being processed on. So only going to a fair data frame doesn't get you very far. You have to also describe all the other components in the workflow or the environment, from instrumentation and collection of raw data to the visualization output products. So.
Yeah, I mean, that's about building the graph, of course.
Yes.
But this is the aspect, I think, of the graph and the information and the linkages that are really going to help you with processing things. That's really the graph. Dieter, I think, has been up his hand off and on.
So I'll just try to speak up. Dieter van Uitvang from Plenary, a research infrastructure dealing with language data and tools. And I think one of our typical use cases is kind of batch processing of large amounts of language data. And from that perspective, I think kind of the picture, at least, that FDO is sketching, like having quick possibilities of checking what is really inside the digital object, also dealing with complex objects like collections and so, would be very welcome to have. Of course, I mean, and that's maybe the side note I should make to that. There's a kind of window of opportunity also time-wise. So we've been looking into the FDO concept already for quite a while, but at the same time, we need to deliver things. And so there's a bit of a risk there that there's kind of parallel constructions coming up. We're currently working on kind of framework called Digital Object Gateway with plugins. And one of the plugins that we foresee is for fair digital objects. But of course, a lot of the uptake, so to say, depends on also the availability of working solutions. I'm not saying that you as working group should all deliver those, because it's a kind of community responsibility, I would say. But I would like to echo Carol's recommendation of doing things there in a kind of open source spirit to ensure that there's kind of full transparency, which will also make our life easier towards, say, selling FDOs to our community. It helps a lot if there's transparency, if you as a relative outsider can follow the process, and if you get kind of regular updates on what is happening. And yeah, we're also willing to contribute.
Dieter, may we directly invite you for one of our project chairs? No, yes, I think, Boris.
Yeah, so Bob Hanish from NIST, and full disclosure, I'm a member of the FDO Forum steering group. In November at the FDO Forum first meeting, I basically said exactly what Carol said, which is why I have confidence I back you up. But I just want to put my view of FDOs in a bigger context. You know, before email, we still managed to communicate. And before the internet, a lot of groundbreaking science was done, right? So do we need FDOs to do science? No. But because of email, we communicate much more effectively. Because of the internet, we do collaborative science much more effectively. So the potential of FDOs, in my view, is to do science much more effectively than we do now. And especially in the context of interdisciplinary research, where maybe you can discover data or software or workflows through FDOs that you're not aware of now, and utilize those in versatile ways that you can't do now. It's not an easy reach, right? This is not trivial, but I also think it's a goal worth reaching for, because the potential is really tremendous. And I think it ought to be technology neutral, whether you implement FDOs against HTTP or against DOIP or against XYZ, I don't know. But it ought to be, as Carol said, I think based on a pattern that can be implemented in multiple ways. So I don't think, and I also think the openness is critical. I said that in November. I say that within the FDO steering committee. I say it within like RDA Council, where I'm also an outgoing member. I characterize myself as kind of a pain in the ass for these groups, but unless you say it inside, it's never going to happen to the outside. So I'm fully in favor of the openness, sharing the specs, getting more and more work examples out there, and working with the willingness of people in the community to help us to create those work examples.
So thank you very much. Thanks a lot that this has been recorded. Because it was a wonderful wrap-up.
Can I make two quick points? One, I think everybody knows this, but it's worth reminding. The Fair Digital Object Forum does not own Fair Digital Objects, right? Fair Digital Objects can be in place without the Fair Digital Object Forum. They're one group who are working on Fair Digital Objects, and many groups are working on things that are in a similar space. So FDOF does not own Fair Digital Objects. The second one is we got away from Fabric, which is unfortunate, because we had two good talks from the gentleman from China and from Nicholas about the actual fabric of FDOs. We started debating FDOs versus talking about the fabric of services necessary to implement that. So something to remember for next time. But I think the FDO as a concept is more controversial and takes on conversation much quicker, but we should be here to talk about that fabric and those services that enable a fair digital object to be utilized in research. So those are the 2 points I wanted to make, and I welcome any feedback, but we'll also hand this back over to Rainer to wrap.
Yeah, thank you very much. We had now.
I think I saw one hand. Yes, please. If you're quick.
Okay. Malte Elling from DISCO, Digital Infrastructure for Scientific Collections in Europe. We are implementing FDOs large scale, meaning that we aim to use them for about 1 to 2 million subjects. I want to reflect on the first question. I don't know if everybody needs FDOs, at least not at the moment, but I think everybody who works with data and wants to make our data fair wants FDOs, because FDOs are really the most simple representation of data in a fair way, and a way to just to describe them uniformly, technology independent. So I think everybody who works with data wants FDOs really. We think that and that will give these new opportunities for interdisciplinarity, etc. If you put machine actionability on top of that, then the potential will be even bigger. And in our case, I think we really need FDOs because we have such a large amount of data. It's also very complex, and just humans cannot navigate that volume of data quick enough to discover new relationships, etc. So we need to have infrastructure that machines can navigate to do part of the science for the scientists, and to make our data navigatable by artificial intelligence machines. We need this kind of infrastructure.
Thank you very much. So now just 1 minute for wrapping up. Thanks a lot for these many controversial views and so on. It's very clear. We need more transparency. We need demos. We need examples. We need the implementations and so on. As an IG here in RDA, we can't solve it all. Definitely not. We are kind of a communication platform. We bring together these guys. And we are still, as an IG, working on it, at least for the explanation and for the exchange. So I would like ask all of you, first of all, thank you for these really great discussions. But again, I would like to ask you if you have some ideas how we can improve as an interest group of RDA. We can't solve the world and all the problems in the fair digital object world if we don't want to. But if you have any suggestions how we can improve as a working group, as an interest group, which kinds of project shares, Dieter, for example, this is wonderful. If you have other example implementations, please put it into the protocol or into the notes, or just write Rob, Lori, Maggie, or me, or all of us, or just to the mailing list, and give us some ideas what we can communicate. We invite everybody to contribute in here. Having said that, thank you very much, and I give the last word to Maggie.
And please do join us every fourth Thursday.
Yeah.
Every last, at the meetings, because we are there not just for ourselves, we are there for you guys. And of course, you don't need to be a member of our group to join us, but if you join the group, then you will also get our reminders of the meetings and then all the other messages will be mailing list, of course. So do join us.
Thank you very much.
Thank you.